welcome back. We're still looking into the chemical change, but now we want to zoom our attention into, practical examples, so that at the end of it all, we kind of get a sense of exactly what happens in a chemical change, and would look at, practical examples in terms of, substances actually reacting with each other. And I think at the end of the day, we would realize that, in as far as the chemical change is concerned, it's definitely what we would refer to as, we would always refer to it as a reaction, okay? Now, let's see what happens in a chemical change, right? Okay, what are some of the important characteristics of a chemical change? Energy is involved. We have seen that energy actually plays a pivotal role in terms of phase change with respect to a physical change. But similarly, for a chemical change to actually occur or to take place, we actually need energy in terms of heating. It could be cooling, either way, but we are safely saying that energy is involved in any type of a chemical change. Furthermore, what is very, very important that actually separates a chemical change from the other types of change is that there is formation of new substances. Okay, we'll understand that in more detail as we look into, the practical examples of chemical changes that we may familiarize ourselves, with. Okay, and then also there is a combination of elements, right? Now, remember, by now we understand the, the unique properties or characteristics of an element and a compound as forms of pure substances, right? That elements consist of atoms of the same kind, while compounds actually consist of atoms of different elements chemically joined together. So now, in a chemical change, we are simply saying that there is formation of new substances. Now, there is rearrangement of these particles that makes up the individuals, reactants to form new substances. All right. So an example of a chemical change that we may be familiar with is that of combustion, which has to do with the burning of a substance in excess oxygen, in a lot of oxygen. So if you take, for argument's sake, a substance like hydrogen, burning in oxygen. So there is a lot of oxygen, okay, and a certain amount of hydrogen to form a product. So in this chemical change, these two substances, oxygen and hydrogen, are actually our reactants, okay? They're actually our reactants, and then water is actually our product, okay? We need to be very careful in as far as, us saying that new substances are formed. However, the new substance, which is a product, actually consists of particles that make up the reactants, okay? So if we were to represent this combustion, because by now we are familiar with chemical formula. We know that hydrogen is actually, a molecule of an element, okay? So we would say hydrogen, which is diatomic, okay? Usually hydrogen exists as a gas. Now, remember the difference between a molecule. A molecule can either be a molecule of an element, meaning that it consists of atoms of the same kind, as is the case with hydrogen. Or it can be a molecule of a compound, meaning that there can be two atoms of different elements, but these atoms are chemically bonded together. So this is as far as classification, just to remind ourselves. So hydrogen actually reacts with oxygen. Oxygen is another molecule of an element, okay, to give us water, which is a compound, right? It can be a liquid or a gas, depending on the conditions in which this chemical change occurs. So this process of combustion is actually burning in a lot of oxygen. So this reaction, this change will actually stop when all the hydrogen is burnt in a lot of oxygen. Okay, so that's how would actually represent this chemical change. But it's very important for us to note that the particles that make up the product are actually those that are involved in actually making up or they make up the reactants. Okay, so this is a new substance which has got different properties from these that were actually reacted together. As just an example, right? Okay, now what happens to particles when oxygen bends when hydrogen bends in a lot of oxygen. So if we can use particles to model this, let's say we've got very small particles that make up hydrogen molecules, okay? These are molecules, okay? Now understand that these are atoms of the same kind that are chemically joined together. So we are saying that this is a molecule of an element. Plus, let's say for argument's sake, they've got just 2 units and then a slightly bigger molecules of oxygen, all right? Okay, so these are our hydrogen plus our oxygen, right? To give us water. Okay, this is what is happening here. Okay, right. Let's say, for argument's sake, this is the case. Now, why are we saying that energy is involved? For these new substances to be formed, okay? Actually, this is our H2O molecule, all right? For these new substances to be formed, we need energy to actually, break these forces that keep these molecules of an element together, the atoms that make up the molecule, similarly to that, so that we can form new substances, okay? So if you look at it, the new substance that is formed consists of the same particles that we found on the left-hand side. So this is typically what happens in as far as a chemical change is concerned. We've used combustion, which is burning in oxygen, as a specific example, right? Okay, now if we are to represent combustion, right? So the word, version of this change is that hydrogen, that's the name, and oxygen to give us water. So the hydrogen, we've said that it consists of molecules of this sort, okay, plus oxygen, which is slightly bigger, but both of them are molecules of an element. Now, the arrow that points from left to right, it shows us that if these two react with each other, they give us a product, which is water. So that's how we represent this chemical change. So this is actually a new substance that is actually formed. So that's a new substance. So this new substance that is formed would describe it generally as a product. Okay, and then these two are actually our reactants. So by now we know chemical formula. We've said that that's the symbolic representation, okay, right? Plus oxygen, okay, another diatomic to give us what? H2O. So that's the different ways in which we can represent a chemical change, right? Okay, now let's look at a different example of combustion. In this case, we're talking about carbon and burning in a lot of oxygen to give us carbon dioxide. So carbon consists of atoms, okay, right? Let's say we've got 2 units, plus oxygen, which actually consists of what? Molecules of an element, okay, to give us a product, which is carbon dioxide. So that's, there's carbon, and then there are 2 oxygen there, right? So this is the new substance that is formed. So in terms of the symbolic representation, remember, chemical formula is something that by now would be very much comfortable with. We can actually represent, this chemical change using the symbols, as in the periodic table, But remember how each of these substances. Now, in the periodic table, you actually have elements, okay? But the manner in which some of them exist, like we've seen with oxygen and hydrogen, which exist as diatomic molecules, of an element, they form compounds. So the periodic table becomes our point of reference for now in as far as the symbolic representation of a chemical change. So we've got carbon, which is C, okay, plus oxygen, which is O2, to give us a product, which is CO2, right? So that's the different way in which we represent these chemical changes. But what is important is that at the end of it all, there is formation of new substance. But this new substance, CO2, consists of particles that are actually making up the reactants, which are on the left-hand side of this chemical change, right? Okay. So when we burn something in carbon, even in terms of the carbon, it can be wood, you think of it in terms of wood, and then oxygen, which is a gas, okay? So this is actually solid in most cases, right? And then plus oxygen, which is a gas, okay? So in representing a chemical change, it's also important for us to indicate the phase at which a material or a substance exists. And then this carbon dioxide that we get is usually a gas, right? Okay, there will be some residue which is left, but the carbon dioxide that is obtained, which is a new substance, is actually in a gaseous form. So that's how we could represent this type of a chemical change, right? Now, we can also look at a different one, okay? Like metals reacting with oxygen. But what is important is that as long as a chemical change is referred to as combustion, it means it involves burning of a material or a substance in a lot of oxygen, okay? Then if there is a lot of oxygen, we would describe that combustion as complete combustion. So the burning process will only stop once the other substance that is burning in oxygen has burnt completely, right? Okay, so here we've got a metal plus, oxygen to give us, an oxide. So in this case, we have got iron, which is a metal. So iron, it consists of atoms of an element, which is, these are the particles that make up iron as a model, and then plus a diatomic oxygen, okay, to give us what? Iron oxide, okay? Iron dioxide, will get something like this. So if we are to also shift gears and look at it in terms of the symbolic representation, what do we have? We've got iron, which is Fe, okay, plus oxygen, which is O2, to give us, if we go back to the name of the product, which is the new substance that is formed, which is iron dioxide, it means it's Fe, okay, O2, right? So this is actually what is happening. Now, if we are to also think of it in terms of, the phases, because we know something now about, the phases of matter. So what are we saying? We would say in a nutshell, this iron dioxide, we need to also check carefully the chemical formula. Okay, iron dioxide, there needs to be, 2 atoms of oxygen for every atom of iron. But generally, the emphasis is the fact that what is happening here is that new substances are actually formed, right? Okay, that's as far as that is concerned. We can also get, a combustion reaction or chemical change. What happens to the particles? Oxygen is a molecule like that. So for the role of energy in this chemical change is that the energy must be used to break these particles so that we can get new substances. Remember, iron exists as atoms of an element. So iron trioxide actually says to us that we have got, let's say for argument's sake, Fe2O3, okay? This is the chemical formula, which is actually the symbolic representation. But in a nutshell, what are we saying? We are saying that as long as combustion, as an example of a chemical change, takes place, there is formation of new substances, okay? There is formation of new substances. That's the main idea in as far as, a chemical change is concerned. So there is a host array of, of changes that we can look at. But at the end of the day, what are some of the characteristics of a chemical change, okay? There's changes to compounds. It can be in the form of a decomposition type of a chemical change, where you start with a complex substance, say for argument's sake, you have these, okay, breaking down into, that, and for argument's sake that. So from simple to complex, it's a chemical change. These are new substances, in a nutshell, are formed from this. And this type of change can be referred to as a decomposition type of a chemical change, which at a later stage you'll be able to actually look into the actual, reactions. Okay, so copper oxide, which is CuO, okay, breaking down to copper plus O2 as a typical example. Okay, so this is an example of a decomposition type of a chemical change in which new substances are formed. So, but if you compare the substances on the left of the change and those on the right, they're actually made up of the same stuff. However, the combination is what is different. So in terms of physical properties, when you look at copper oxide, it will have different physical properties as well as chemical to copper and oxygen, which are our products, right? So this is what is actually happening. And the role of energy is very important. To break down, you need energy so that the bonds that exist between molecules, compounds, can actually be broken down, right? So there's quite a lot of examples, but these are just simple ones. In some cases, we use electricity to break down, let's say, copper chloride to give us copper and chlorine. Copper chloride is actually a compound, right? And then copper and chlorine are actually simpler substances, which are elements. So these actually represents the different types of chemical changes as examples. So in a nutshell, what happens in a chemical change? New substances are formed. Okay, and the chemical and physical proposition or properties of those materials will definitely change. So that's as far as the chemical change is concerned. For now, we shall call it a day. Goodbye for now.